This video is on ideal gas law calculations to find density of gases and molar masses of gases. So the first kind of equation we can use is we can calculate the density of a gas using our ideal gas law. So our ideal gas law is PV is equal to nRT. Now if we're at standard temperature and pressure, STP, I know that my temperature is 273 Kelvin. And my pressure can be any one of the standard pressures, 1 atmosphere, 760 millimeters of mercury, 760 torr, or 101.3 kilopascals. I'm going to use ATM. That also means that my R value, my gas law constant, has to match up with my pressure units. So my R value for atmospheres is 0.082, and that has units of atmospheres, liters per mole Kelvin. When I'm looking to find the density, I know that density is equal to grams per 1 liter. I always know that my units on the bottom are 1, just like for molar mass it's grams per 1 mole. So that means that I also know that my volume is equal to 1 liter in this case, because I want to find the density, so the number of grams of helium inside of 1 liter. So I have T, P, R, and V, which means the one thing that I don't have right now is I don't have N. So that means that I can use my number of moles, N, and I convert moles to grams using the molar mass of my helium, which is 4.003 grams per mole. So to do this, I'm going to set up my equation solving for moles first. And then once I get moles, I'm going to convert my moles to grams and divide by my 1 liter to get me my density, which is my number of grams per 1 liter. So my equation of moles is PV over RT. I plug in my values of 1 atmosphere times my 1 liter divided by my 0.082 times my standard temperature of 273 Kelvin, and you would have units in. And that gives me a number of moles of 0.0447 moles of helium. Now to find density, I need it in grams. Therefore, I'm going to take my 0.0447 moles. I'm going to convert, I know that 1 mole is 4.003 grams. And that is going to give me 0.179 grams. And remember, back up here, I did this in 1 liter. So that means my volume is still 1 liter, so it's grams per liter. And so my density of helium is 0.0179 grams per liter. Now the other type of calculation I can do is I can calculate the molar mass of an unknown gas given its density and the pressure and temperature. So from this, I know my density, and if I know density, I know my number of grams per 1 liter. I also know from this equation that my pressure is 745 millimeters of mercury and my temperature 296 Kelvin. I also know, given my pressure units, that my R is going to be 62.4 millimeters of mercury liters per mole Kelvin. And again, I'm going to use the fact that because I'm given density of this many grams, 109 grams per 1 liter, that my volume, again, is 1 liter. So whenever you're dealing with density, you are assuming that you have 1 liter because that's what your density is measured in, so many grams per 1 liter. So molar mass is given in units of grams per 1 mole. Okay. I don't know how many moles of gas are inside of my 1 liter container because I have currently 1.9 grams inside that 1 liter. I don't know how many moles it is because I don't know my molar mass. What I do know is I do know how many grams I have from my density equation. So the thing that I'm really looking for in this calculation is I'm looking for my number of moles. So that way, in the end, I can take my grams, my 1.9 grams, and divide it by the number of moles I find using my Pivnert equation, solving for n. So just like before, for calculating density, we had to solve for n, our number of moles. We're going to do the same thing here. So n is equal to PV over RT. I plug in my information, 745 millimeters of mercury, my volume of 1 liter, divided by my R value, 62.4 millimeters of mercury liters per mole Kelvin, and my temperature of 296 Kelvin. When I plug this in my calculator, I get 0.04 moles of my unknown gas. So now I have my value, which I can plug into my molar mass equation of moles. I also have my value of 1.9 grams that I can plug into my molar mass equation. So now molar mass is equal to grams over my moles. I have 1.9 grams divided by my moles, 0.04 moles, which gives me a molar mass of 47.5 grams per mole. Okay, so looking back over this, I'm given density, which tells me how many grams I have in my 1 liter. That 1 liter tells me my volume. You'll always be told your pressure, your temperature, and from your pressure units you can calculate R. This means you have everything but your moles, because molar mass is grams per mole. So you solve your ideal gas law for moles. Once you have moles, you solve for your molar mass by taking your grams given to you in the density and divide it by the number of moles you have. Okay. Go ahead and now go back over and try to do each one of these problems on your own and check your work to make sure that you get the right answers for both of these and you understand the work you have.